All right, using chords of circles. Now remember, a chord goes from one point on a circle to the other point of a circle. So it says find the value of x given that C is the center of the circle and that circle has a diameter of 12, right? So we're talking about from here, okay, let's see if I can get my pen to work. From here to here is 12, which means this is 6, and this is 6, and this is 6, because those are all radii. All right? Well, what do we have here in number 1? We have a 45, 45, 90 triangle. Okay? So, if we're trying to find x, that is the hypotenuse. And going from the leg to the hypotenuse means we multiply by radical 2. So that means that chord is 6 radical 2. All right? So what we have here is, we know this is 6 and this is 6 because all the radii are 6. All right? Now, here's the thing. Now 6 is our hypotenuse. Now notice what we have here. These two segments are equal. If this is 6 and those two pieces are equal, that means this is 3. But what do we have there? Let me just kind of draw this out a little bit bigger. What we have here then is 3 and 6. Notice the 2-to-1 ratio. That means this is the small side. This is the hypotenuse. So this is the medium leg. So we're going from here to here on a 30, 60, 90. That means this is my 30 and this is my 60 here. So going from the small side to the medium side, remember, we multiply by radical 3. So x equals 3 radical 3. All right, now, in this case, these two chords are equal to each other. So we're going to say x plus 8 equals 2x minus 3. So I'm going to add 3 to both sides, which will give me x plus 11 equals 2x. I'm going to subtract x from both sides, and I get x equals 11. All right, so more theorems, of course. Congruent corresponding chord theorems. In the same circle, or in incongruent circles, two minor arcs, okay, so remember, a minor arc is this right here, okay? This is the minor arc right here. Okay, it's less than 180. It's less than the diameter. Two minor arcs congruent if and only if their corresponding chords are congruent. So when you see this is equal to that, then you know this is equal to that. So if the chords are congruent, then the minor arcs are congruent. Perpendicular chord bisector theorem. Lots of words. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so what happens here is, since we have a right angle here going through FD, that means FH and HD are equal and FG and GD are equal. Those chords are equal. That's only when you have it perpendicular. And then you have the converse. If one chord of a circle is perpendicular, if one chord of a circle is a perpendicular bisector of another chord, the first chord is its diameter. All right? So remember at the beginning I told you how a diameter is also a chord? So what it's saying is, if one chord is a perpendicular bisector, so since this chord bisects TR, then you know SQ is a diameter. Okay, so think about it. If I had a chord like this and a chord like this, even though it's a right angle, you can tell that neither of these are bisected. So neither one of them is a diameter. All right, in the diagram, circle P is congruent to circle Q. FG is congruent to JK, and MJK is 80 degrees. I'm sorry, not MJK. The measure of JK is 80 degrees. Find the measure of FG. Okay? So, since the two are congruent, the two circles are congruent, and we know this segment is equal to this segment, that means this minor arc is the same as this minor arc, so it's 80 degrees. All right, find HK, and then find the measure of arc, minor arc HK. All right, so we have a diameter, JL. We have it perpendicular to HK, which means JL bisects HK. So we know this is equal to this. So since KN is 7, that means HN is 7, which means HK is 14. Now, we also know then this arc is equal to that arc. Okay? So 11x equals 70 plus x. If I minus x, I get 10x equals 70, which means x is 7. That's not what we're asking for. We're trying to find the measure of HK. HK is this entire thing right here, which means we need to find out what each of those pieces is. So if I plug in 7 here or 7 here, I get 77. Double that, 154 degrees. Because each of the little arcs, HJ is 77, JK is 77. Combine them together or just double them, you get 154. Another theorem, equidistant chords theorem. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so EG and EF, if those are the same distance, that means CD and AB are equal. Only if that happens. So let's look at what we got here. In the diagram, QR is equal to ST. So we know QR and ST are equal. It says CU is equal to 2x, which is labeled. And CV is 5x minus 9. All right, well, that means this is the distance and this is the distance. Since the two chords are equal, that means the distances are equal. It goes both ways. All right? So if the blue lines are equal, the red lines are equal. If the red lines are equal, the blue lines are equal. Okay? And that distance to the chord always has to be 9 degrees. That basically means this is equal to that. So 5x minus 9 equals 2x. I'm going to subtract 5x. Now, usually I don't do this because I like to keep them positive, but there's no reason to move the 9 also. So that's going to give me negative 9 equals negative 3x. Pay attention to your negatives. Divide by negative 3, and we get x equals positive 3. But it doesn't say find x. It says find the radius. So we have to do a little bit more work here. Now, we have to do a little bit of thinking here. Let's go back to the fact that we know that QR and ST are 16. Okay? If we look at WX, which is the diameter, and it's 90 degrees, it's perpendicular to QR, that means these two segments are bisected. That means this is 8, and this is 8. We also know if we plug in the 3 for X, that this is 6. So the radius is going to be the hypotenuse of a right triangle. So we just do 6 squared plus 8 squared equals C squared. So that's 36 plus 64 equals c squared. That's 100 equals c squared. Square root both sides, and c is 10. So the radius is 10. That's a lot of work, I understand, but you just got to go step by step and break it down. And you kind of got to combine all the knowledge we've learned so far. And that's it, though.